Hello, welcome to my channel Ganitha Vahini. I am HarshaVardhana. In previous session, we solved problems about permutations. Today we are going to see about combination. A combination is a mathematical selection of items from a large set where the order of selection does not matter. It determines the number of possible subsets calculated using the formula NCR is equal to n factorial over r factorial into n minus r factorial, where n is the total items and r is the items chosen. Unlike permutations, combination focus on grouping, not on arrangement. Before going to learn the formula NCR, let us recall what is NCR. NCR is the number of ways of selecting some objects out of given objects where the order of the objects does not matter. NCR is equal to NPR over R factorial, that is equal to n factorial over r factorial into n minus r factorial. It is widely used in probability and statistics. NCR formula has a wide variety of applications in real life as well as like it can be used for number of ways of forming a team or a committee. Hence, it plays a vital role in solving combinatorial problems. Let us learn the NCR formula along with a few solved example. Next, we go to the derivation of the NCR formula. Let us recap. NPR or P of NR formula, the number of ways to form a permutation of R elements from a total of n elements can be determined by forming a combination of R elements out of total of n in any one of C of NR ways. Ordering these R elements any one of r factorial ways. By fundamental counting principle, the number of ways to form a permutation is C of NR into r factorial. But this is nothing but permutation P of n comma r. That is, P of n comma r is equal to C of n comma r into r factorial. Using the formula for permutations, P of n comma r is equal to n factorial over n minus r factorial. To substitute into the above formula, n factorial over n minus r factorial is equal to C of n comma r into r factorial. On solving this, the number of combinations C of n comma r is equal to n factorial by r factorial into n minus r factorial. Let us check out a few solved examples to understand more about NCR formulas. Before going to formulas, let us know about the relationship between permutations and combinations. Permutations and combinations formulas and concepts have a lot of similarities. Suppose that you have n different objects, you have to determine the number of unique or selections, that is selections of contain or objects which can be made from this group of n objects. Think of a group of n people. You have to find the number of unique subgroups of size r, which can be created from this group. Therefore, the number of permutations of size r will be NPR. In the list of NPR permutations, each unique selection will be counted r factorial times, because the objects in an r selection can be permutated amongst themselves in r factorial ways. Thus, the number of unique combinations can be NPR by r factorial. Therefore, NCR is equal to NPR by r factorial, that is equal to n factorial by n minus r factorial into r factorial, that is n factorial over r factorial into n minus r factorial. This is the formula for NCR. We have some difference that in permutation column we have permutation is the total number of ways to arrange elements from a set, and in combination, a combination is the total number of ways to select the elements from a set. In permutations, the order matters. In combination, order does not matter. And in permutation, example is on tossing the three coins, HHT and HTH are the different because the order is important. And in combination, the example is in combination of HHT and HTH are the same because the order does not matter and does not matter. In permutation, used for arrangements of rankings, seatings, passwords, etc. Combination is used for selecting committee, teams, lottery, choosing items, etc. Whenever you read the phrase number of combinations, think of the phrase number of selections. When you are selecting the objects, the order of objects does not matter. For example, x, y, z and x, z, y are different arrangements but have the same selection. The number of combinations of n different objects taken or at a time where r is less than n is NCR is equal to NPR over r, that is n factorial over r factorial into n minus r factorial. This results above is derived from the fact that in the list of all permutations of size r, each unique selection is counted r factorial times. Out of n objects, the number of ways of combinations 0 or n object is 1, and the number of ways of selecting one object or n minus 1 object is n. Out of n objects, the number of ways of selecting two objects is nc2, that is n into n minus 1 by 2. A few important results on combination are as follows. The number of ways of selecting n objects out of n objects is ncn, that is n factorial over n factorial into n minus n factorial, that is n factorial by n factorial into 0 factorial, that is equal to 1. The number of ways of selecting 0 objects out of n objects is nc0, that is n factorial over 0 factorial into n minus 0 factorial, that is equal to n factorial by 0 factorial into n factorial, that is 1. The number of ways of selecting one object out of n objects is nc1, that is n factorial over 1 factorial into n minus 1 factorial, that is n into n minus 1 factorial by n minus 1 factorial, that is equal to n. And NCR is equal to NCN minus R. Therefore, and NCR plus NCR minus 1 is equal to N plus 1 CR. Examples using NCR formula. Find the number of ways to select 3 books from 5 different books on the shelf. The total number of books n is equal to 5. The number of books to be selected r is equal to 3. The number of ways selecting 3 books out of 5 books is 533. By NCR formula we have 5C3 is equal to 5 factorial over 5 minus 3 factorial into 3 factorial, that is equal to 120 by 2 into 6, that is equal to 10. Trevor has to choose 5 marbles from 12 different colored marbles. In how many ways can she choose them? Trevor has to choose 5 out of 12 marbles. As order does not matter, here we use NCR formula. He can choose it in 12C ways. 12C5 is equal to 12 factorial over 5 factorial into 12 minus 5 factorial, that is 12 factorial by 5 factorial into 7 factorial, that is equal to 12 into 11 into 10 into 9 into 8 into 7 factorial over 5 into 7 factorial, that is equal to 12 into 10 into 11 into 12 into 11 into 10 into 9 into 8 over 5 into 4 into 3 into 2 into 1, that is 792. John asks his daughter to choose 4 pens from the basket. If the basket has 18 different pens to choose from, how many different possible ways she can do it? Given r is equal to 4, that is subset, n is equal to 18. Therefore, we need to find 18, choose 4. Now the combination C of nr is equal to n factorial over r factorial into n minus 4 n minus r factorial, that is 18 factorial by 4 factorial into 18 minus 4 factorial, that is 18 factorial over 14 factorial into 4 factorial, that is equal to 3060. With this problem, I will conclude this session. If you have any doubt or clarification, please read the same, and those who like the video, please subscribe it, share it and like it, and those who didn't watch the video or listen the video, please put in the comment box. I will rectify your comment, and if you doesn't see the videos, I will put the link in the description box. You can see the description box and click on the link and see the videos.